Welcome to the Treehouse Show podcast. All right, welcome to a new episode of the Treehouse Show podcast. My name is Dustin. I'm the host, and with me we have Guy Royse again.
Hey, how's it going? It's nice to be on the show again. Do we call it a show or do we call it a podcast? Or it's nice to hang out with you again. We'll go with that, right?
Yeah. Call it the podcast, the show. It doesn't matter. No
the,
real
the, the
official
the pod
name.
show. Yeah,
Just two guys hanging out. That's basically all it is.
yeah,
So I did mention in your last episode that you were with us that you had a really cool app that you built that you wanted to share. So if you want to talk about it, I'll let you take over.
yeah. Sure. So I'm happy to talk about it. I'm not really in a situation where I can screen share easily today, but I can talk about what I've built, and you can go check it out. I have built a fun and ridiculous thing using all of the coolest and hottest new buzzwords, most specifically vector search or embeddings or AI. It's all that kind of stuff, right? Um,
Mm-hmm.
and what I've done is I've taken this glorious data set of Bigfoot sightings. There are 4,586 Bigfoot sightings in this data set, and they have great fields. The data is full of stuff, all kinds of. It's full of gold. The data is full of gold.
Yeah.
It's got a full eyewitness account of the Bigfoot sighting, and they've got classifications for the Bigfoot sightings. So, like a Class A Bigfoot sighting is I saw Bigfoot. A Class B is I saw evidence of Bigfoot, or like a footprint or something like that. And then Class C, which is someone told me they saw Bigfoot,
Yeah.
which is the most reliable of all of them.
Right.
Secondhand. I suppose technically they're all Class C at this point because I heard them from someone else. But
Yeah.
but the idea is that that's a category of. My grandfather told me when he was a kid he saw Bigfoot down by the river. That sort of story.
Yeah.
And so and it's got like the weather information and all kinds of really latitude and longitude, all kinds of great data. And so I've been playing with this for projects off and on for years, just showing how to like search things. So I work for Redis, and so of course I'm going to show off this data off with Redis, and so I would use Redis search to find Bigfoot sightings that were interesting. So it's like, give me all the Class A Bigfoot sightings that happened in Ohio or Kentucky, and was within 50 miles of Cincinnati, and the temperature was above 80 degrees Fahrenheit, right? So you could build those sorts of queries and query it. But
Right.
this isn't really anything. I mean, it's nice that you could do that, but this is really no different than shoving all those Bigfoot sightings into a relational database and saying select star from Bigfoot sightings where condition. So I've added a vector search component to it to make it a little more compelling. What I've done is I've taken the Bigfoot sighting text, that eyewitness account. I saw Bigfoot down by the creek, and he was he's big and hairy and scary, and he was washing his food down there in the creek. Yes, I wash things in the creek. When you're telling a Bigfoot story that happens in Kentucky, this is how you say it. If anyone's offended by that, my grandfather's from Kentucky, and I say this out of love, and this is actually how I talked when I was a kid.
Little disclaimer.
Yeah. Well, so full disclosure, I'm one generation out of the trailer park and two out of Kentucky. This is actually how I grew up talking. So you take that story, right, and you can turn it into an embedding or a vector. And this is sort of a complicated concept, but in some ways it's not, which is how a lot of AI works. There's like a lot of complicated math, but you can intuit how it works, get an approximation that works for you to think of it intuitively as a human, as a developer who doesn't need to know how the algorithm works. You just need to use the algorithm.
So for those that don't know, can you explain like what a vector is?
Absolutely. A vector, the vector in vector search is more basic than AI. A vector in this sense is just an array of numbers, or perhaps a multidimensional array of numbers. In data science, they tend to use the idea of a scalar, a vector, a matrix, and then a tensor as sort of like add a dimension each time. So like a scalar is just a number, and then a vector is a collection of numbers, and then a matrix is a two-dimensional array of numbers, and then a tensor is a three-dimensional array of numbers. And that's how people tend to talk about it. Mathematically, that's wrong. That's not what these mean, and there's more subtle and sophisticated definitions that are beyond my ken, right? It's not a...
Mm-hmm.
So when I say vector, usually it means it in that sort of one-dimensional array sense when it comes to
Okay.
vector database. And so you literally just have an array of numbers, and what you're doing is you're looking and saying, how similar is this array of numbers to another array of numbers? And so what vector search does is it just says, well, I've got this vector of, like, say, 50 numbers, and I've got another vector of 50 numbers. And if I think of that as coordinates in a 50-dimensional space, they're more similar if they're closer to each other.
Right.
And so to visualize that, it'd be better to do a two-dimensional thing. And so you got a vector of just two numbers. They're just your x and your y. And if
Hmm.
I've got an x and a y where I draw the line between them and it's really short, versus x and a y where the line between another set of coordinates is really long, then the shorter line is going to be closer and
Right.
therefore more similar. And so that's what vector search does, is it just compares these. And there's a couple ways to do that. One way is you could look at them from like the middle of that XY plot from origin from 0, 0, draw a line to each point from the origin, and then measure the angle. And the more narrow the angle, the more similar they are. And the
Gotcha.
wider the angle, the less similar. Now that, however, if they're on the same angle and really far apart, maybe they're not as similar as you think they are. And so it's slightly flawed. Or you can just draw a line between them, and then if they're the shorter the line, the more similar they are. So this is what vector search does.
Okay.
Okay,
Cool.
so
Cool.
that's a lot of detail about why the heck do I care about this, right? Right. Um, and so this is where the AI part comes in. And so what you can do is you can create what's called an embedding. An embedding is just a vector that is contains coordinates to a high dimensional space, so maybe like 134 dimensions or 50 dimensions or whatever.
Okay.
And an AI model will spit out these vectors, and the closer for whatever input you give it. And if the input is about the same thing, then it's going to put out similar vectors or similar embeddings. And so you're taking like the semantic meaning of a bunch of text, and you're turning it into a set of coordinates. And if you have the semantic meaning of another bit of text and they're similar, the coordinates are going to be close to each other, and then you can compare them.
Gotcha. Gotcha.
Right? Using all that stuff I just described. And so you can do this with images, you can do this with sound, you can do this with text. If you do it with text, you're using an LLM. And so I took the eyewitness account of Bigfoot sightings and ran them through an embedder to turn them into an embedding, into a vector, so that then I could go to a search bar and type in, give me Bigfoot sightings that happened in the desert. And then that would create it, and you create an embedding off my search query, which is going to have coordinates in that space. And then I can compare that to all the ones that are in Redis and find the ones that are most similar to that have the concept of a desert in them, that are closest to that.
Hmm.
And so that's what. And so I built all this, and so you can type in and say, give me Bigfoot sightings that involve alcohol and happened at night, right? and then it will, and the LLM is smart enough to know that homemade apple wine, whiskey, and Natty Light are all alcohol, right?
Yeah.
And will then figure that out, and it also understands that night and darkness and other things about that are night. It knows that this happens at night because it can read the context, the semantics of the content, and puts night alcohol related things in a particular space in the embedding, and so it ends up
Gotcha.
with coordinates.
It
And
seems so
so
complex, but so simple, you know?
yeah, well, the magic is really in the it's really in the AI model that's happening. The vector search itself isn't particularly complex. I mean, the algorithms to make it efficient are sophisticated. I don't want to say it's
Right.
simple, but from an end user point of view, you pretty much have to say, well, here's how big my vector is, how many dimensions there are in the embedding. This is, and then tell it whether you want to do like the cosine, the angle measurement, or whether you want to do the Euclidean, the distance between the two coordinates for your search, and you can do a dot product as well, which I kind of understand. I don't have a very mathy background, um, and but you can use these different mechanisms. They have some pros and cons, which you can kind of learn with rules of thumb, and you can just use it. The magic has happened in the AI space. The
Yeah.
The algorithms are just there. They just do what they do. Um, and so, yeah, so I built, this is the silly thing that I built, a Bigfoot finder where you can say, give me the Bigfoot sightings that are in whatever kind of topic you want. The thing that was really
So
cool. Oh, so go ahead. Go ahead.
no, I was just gonna say, so like how long did this take you, like from like conception to just finishing it?
Uh, well, I had a lot of learning to do, so I had to learn a lot of the things I just explained. So it took me a couple of weeks to put all this together because I just
Gotcha.
needed to learn the tools to make it happen. Um, and I kind I did it with one arm tied behind my back because I wanted to do it in JavaScript specifically. So I had two criteria that I wanted. One is I wanted to use JavaScript because I wanted to show that you could do this stuff from languages other than Python.
Okay,
Uh,
cool.
and two, I wanted to use downloaded local models that you didn't have to pay for.
Ah,
And,
okay.
right. So I wanted somebody able to basically pull this down, install everything with an npm install, and run it without having to flop out a credit card to pay for like
Right.
APIs that do the embeddings for you. And so that made it a little more challenging, is figuring out how to do this from JavaScript, because there's lots and lots of examples on how to do all this stuff with like LangChain from Python, and there is a LangChain JS that has Redis plugins, and so I was able to take advantage of that stuff. But it wasn't. It's sort of not the happy path, and so I went down a more difficult path than I needed to.
Yeah.
But I'm pretty happy with what I ended up building. And then I spent way too much time dinking around with the front end frameworks and which one I should use, and that's a
Yeah. Cool. Just curious, what framework did you end up using?
well, I don't advocate this, but I ended up using Tailwind CSS, which is fine. And I used this framework called Lit, which uh, is a simplified web component framework, and it actually generates web components. The problem is which is really cool, and I like the framework, but it doesn't play good with Tailwind
Oh, does
because
it?
because Lit creates web components, and web components have the they have the
Like
shadow
there's
DOM,
yeah,
which the CSS from Tailwind can't penetrate,
right.
and so then you either have to bring in Tailwind for every component, which is a lot of network calls,
Ooh.
right? Each web component would then have to go out and pull down the entire Tailwind thing,
Oh wow.
or you would have to break the shadow DOM so that Tailwind can see everything. And I went ahead and did the latter, but I do not recommend this.
No.
Uh, Basically, Lit's awesome, Tailwind's awesome. Don't use them together.
Right,
That's my
right.
advice. And so, if
That's
I
like
were,
steak and I don't know, bananas. Both taste great separately. Probably don't taste too good together.
I'm not going to put a banana sauce on. I'm not going to have steak banana flambe. Uh,
Right,
steak
right.
bananas Foster. Yeah, that sounds awful. Uh, that
It
said,
does.
I would have fried plantains with a steak. That would be pretty good, right?
There you go. There you go. So I have one more question for you. Why Bigfoot? Was there a reason behind that being the topic of the build?
Well, ultimately, it's because it's funny. Uh,
Quirky.
right? It's funny. It's quirky. It's a fun theme. And so one of my go-to strategies when I'm making content or doing talks or anything is um, fun theme introduction with a fun theme. And so
Right.
this is really an introduction to how to build something fairly basic using these large language models, using embeddings, using Redis, using vector search, but also fun. And so that's really why I
Yeah.
do that. Now, I like to joke in some of my talks that Bigfoot is my father, uh, which if you are seeing a video of this, you will. Well, maybe in post we can put up a photo. I've got a slide for you. I'll give you to put in post
Okay.
of
Yeah.
just this two Polaroids of Bigfoot and a picture of me eating a turkey leg at a Ren fair, and then they're sort of like at an angle to each other, and it looks like the classic scene where they play the sorrowful music, and it's like, yeah, but Bigfoot's my father. I've been trying to find him, but I haven't seen him in years.
That's
He
funny.
just went out for milk and cigarettes and never came back. You know, I tell this story, and then the talk is then the story of how I'm trying to find my father using it, Redis and
Yeah,
machine
I
learning
can
and data
definitely see how this
science.
would be like a fun introduction.
Yeah, but and I've used this theme for several things on projects over the years. Um, I had built one years ago that used a natural language processing classifier. This was at another company that I used to work for. That would take the Bigfoot sighting and tell you whether it was a Class A or Class B Bigfoot sighting. So whether you saw
Oh,
Bigfoot or
cool.
was evidence of Bigfoot. And so there's the data set's actually really good because it's got numeric, it's got geo, it's got text, it's got lots of things you can do fun search and data science stuff with. And so I've gotten a lot of mileage out of it over the years. It's been a lot of fun.
Cool. So, one really quick question just before we end out the episode. Do you believe in Bigfoot?
I want to believe, but no, I really don't. I just think it's funny.
No.
If Bigfoot was real, I think that would be amazing. And I love this kind of stuff. As a kid, I always
Yeah.
always watched shows about this, and it was super compelling. Bigfoot and UFOs, and if
Mhm.
there's anyone older in the audience that remembers Leonard Nimoy's "In Search of" show, I would watch that. I used to listen to this podcast called Mysterious Universe. I love this kind of content. Uh, but
Yeah.
I don't believe it. I just think it's fun.
No. No, I feel that. I feel that. All right, that is pretty cool. If you're interested at all in the repo, we'll link that down below as well as some extra resources for it if you want to check it out. I think it's really cool and worth checking out for sure. Guy, it was super awesome having you on the show again. We're definitely going to have to get you on here again and talk about some other cool stuff.
Absolutely, I'll talk about anything that you want me to talk about. And I work for Redis, and so I tend to talk about Redis things, but I'm happy to talk about whatever you'd like to talk about.
Yeah, for sure. We definitely need to get some more information about Redis on here. That is something that we do have planned is to kind of dive a little bit deeper into Redis and some use cases for it. So stay tuned for some more episodes with that. But with that, that is the end of the episode. We'll see you guys in the next episode. Until then, have fun and happy coding.
See ya.